Okay, we're live. Good afternoon again, everyone. If you're in room one as well, my name is Lutfi Zuhri, and I'll be your moderator again for this session. We have Pratibha Jagnere as our speaker. Pratibha is a senior software engineer at Silver Sky. Is it correct? Yeah. So she's an enthusiast Pythonista, passionate for coding and books. Through her PyCon talks, she loves to explore and share new things she learned from Python. This talk aims to summarize the common antipatterns in Python. It is overwhelming to see so many resources to learn best practices in Python. But however, it's more scary that there are not very few places which will teach you what you shouldn't do while doing. So if you have any question, you can ask through Hopin. Pratibha will answer your question in Q&A session. So without further ado, let's give a big round of virtual applause to Pratibha Jagnere. Pratibha, the stage is yours.
Thank you, Lutfi. Hi, and welcome to my talk on antipatterns in Python. A big part of developing a product revolves around designing it. If design is good, the development becomes less error-prone. But there are still ways to develop a good design and still end up with a horrible product. These breakpoints are always trivial and tiny, but they have cascading effect in longer run. Let's first discuss what are antipatterns. An antipattern is a solution that, if get implemented, it will counterpart the end goal or the objective we are trying to do. It basically tells us that you should not implement that idea because it is really a bad design. For example, a pattern would be to use function for code reuse. An anti-pattern would be to use copy-paste for the same. Now the question is, why should we learn anti-patterns? Of course, there are many ways to learn how to do good coding practices, but bad code teaches as much as, or sometimes more than, what the good code can teach us. And people will always tell you what you should do and how you can improve your coding, but they will not, or maybe they will refrain from telling you what you should not do or in coding. At end of the day, if something goes wrong in production, it's usually the anti-pattern or the thing that should be written or handled peacefully or silently, properly logged, which is not done. So in this talk, we are going to see the things that we can do to improve our coding. Now, a large part of senior developers' work involve code review of others. They are responsible for high quality and affluent design of the code. Hence, code reviews are rigorous and thorough. We will look into a few categories of code review which are responsible to have anti-patterns in the large scale or in the usual code reviews. First one is the correctness. This includes the anti-patterns which can literally break your production code or make it do the things which it should not do. Then maintainability. It accounts for the anti-patterns that are part of the code which are difficult to maintain. Then we have readability. Anti-patterns that will make your code hard to read or understand. Then at last, performance. Anti-patterns that will unnecessarily slow your code down. Now let's see the first part of our anti-pattern, that is correctness. And we will start with else clause on loop without a break statement. Let's have a code that will look very nice and neat but have anti-pattern in it. The else clause of this loop is executed when the loop sequence is empty. When a loop sequence had no break statement, the else clause will always get executed because the loop sequence will eventually always become empty. Sometimes this is the intended behavior, in which case you can ignore this error, but most of the time this is not the intended behavior and you should therefore review the code in question. Second one we are going to see is assigning a lambda of expression to a variable. Now the sole advantage of a lambda expression have over a definition of function is that lambda can be anonymously embedded within larger expression. If you're going to assign a name to lambda, you better off just define it as a def, because it will be a bad practice. The first form means the name of resulting function object is specifically f instead of generic lambda. This is more useful for traceback and string representation in general. The use of assignment statement can be removed because lambda can offer over eliminate the benefit that lambda provide over the definition. The next one we will see is assigning the built-in function name. Now, sometimes when we are coding, there's a possibility that we will end up assigning a variable name which is actually a built-in function. Now, Python have a number of built-in functions that are always accessible in interpreter. Unless you have a specific reason, you should never override these functions nor assign a value to a variable that have the same name as built-in function. Overwriting might be undesirable, and it can end up, or it can create a problem in longer run, because you will not be able to track the issue that is happening here. Now let's have a look at the next one. Not using set default to initialize a dictionary. In general, this snippet of code we see in many code reviews. First, you check whether a key exists in dictionary or not. Then, if it is not, you initialize it and then modify that key. Although there is nothing wrong in that, but same can be achieved by a built-in function of dictionary that is set default. It will make sure that if the key is not there, it get initialized and it will perform the further action on it. This helps in making your code look clean and more readable, and you're using the built-in method, so it is always better. Now, in general, when we try to retrieve a key from dictionary, we will just go ahead and check if it exists or not. Again, there is no problem in that. But if we use get along with it, it is always better, because what will happen to the data and what the modification of data that is setting it to the message key value in the dictionary, you can merge them into a single line. So instead of having 3 lines, you can go ahead and change your code to this to use the get function, so that you can have the key value and the default response string in the same line. This will always make your code more likable, because you're using the built-in function again. Now, there are many anti-patterns under the category of correctness, but the worst one, the most evil one I found out is only one, because it actually is responsible for causing lots of bugs in production code, and that is no exception type specified. Let's have a look at this code snippet. It is doing what it does. It is doing what it is supposed to do. We have a divide function. It takes argument a and b. If a divided by b is logical, it will return the result, else it will just catch that error. If there is any error, it will catch it and accept and return none. Now, this code will not cause any issue, because if there is any issue, you're catching it into the accept. But involuntarily, we will end up causing problem for ourselves in longer run, because unknowingly we have ended up creating the worst kind of bugs into our program, because we are hiding the error and losing the information about it at the same time. Now, what can go wrong here? You will think there can be many things that can go wrong here. Maybe a and we will not know why a particular a divided by b failed. What happened in there? Is it possible that A and B are not properly the typecasted, or they are not actually the numbers? Is A and B is something other than a number? Or if their division is by 0, what exception is there? Now, this is just an example. There are many ways this thing can go wrong. So to catch exception and then silently continue doesn't seem like an horrible idea at the moment, but this can introduce many production bugs, and they are the worst kind of bugs. Bugs that can escape detection during development and can end up in production, or bugs that exist in production for a long time and without even us realizing it, and they will be hard to troubleshoot because we don't know where to look with, and they will be hard to fix because they are already suppressed, so we don't know where the problem exists actually. What can be done to improve this approach is we should mention exact type of our exception handling. So we are able to handle exception based on their actual exception type. The first exception type that matches the current error is handled first. Hence, it is recommended to handle specific exception type first and generic exception types later. That is towards the end of try except block. The else clause execute only if no exception occur. It is useful to log the success of your code. The finally block executes under all the circumstances, no matter if an error occurred or not. It is useful to clean up the try except code that you have written. In addition to this, what you can do is you can implement your own exception class so that the exceptions that are being raised are more detail oriented, and they will have more knowledge or more logging about the issue that has happened exactly. Now, the next incorrectness is using mutable default value as an argument. Let's have a look at the code snippet. In this one, what we see usually when a programmer uses a list and a dictionary as default argument to a function, the programmer wants the program to create a new list or dictionary every time that function is called. However, this is not what Python does. The first time that function is called, Python creates a persistent object for the list or dictionary. Every subsequent time the function is called, Python uses that same persistent object that was created from the first call of the function. So, how can we handle this issue? We should use the subtitle value, that is none, to represent an empty string. And if it is none, we should explicitly initialize it with the literal that we want to have in that particular argument or the variable. So explicit is always better than implicit. It always helps in making sure that the variable contains the object type or the object, only the object type that it is supposed to have. Now comes the maintainability. A program is maintainable if it is easy to understand and easy to modify the code, even for someone that is unfamiliar with the code base. Hence, we should avoid antipatterns in maintainability, especially avoid creating the spaghetti code. Once again. Sorry about that. So, if you have read this comic strip, you will realize exactly what I'm talking about in maintainability. Now let's look into the maintainability. The first one that caused the issue is using the wildcard imports. When you want to import a library, or when an import statement in the pattern are from module import star, it is difficult to identify or detect the undefined names in the program, because it will be problematic for the reader of that code to understand where it lies, where this particular function is being called from. Hence, as a general best practice, import statement should be as specific as possible and should only import whatever function inside a file that is needed. Or there are some cases when making the import statement specific is not a good solution. So in that case, it is suggested to import the whole module so that you can go ahead and use import the whole module and use it as the to refer the further functions inside it. Now, this is a very tricky maintainability anti-pattern that is returning more than one variable type for a function. For example, this is the function. You pass a password to it or a variable to it. It checks if that string is bicycle or not. If it is bicycle, it returns 42, else it returns none. The problem with this approach is the caller of this function have to keep track of the return data type. That means caller cannot go ahead and rely on the data type or the data that is being written from this function. What will be better in this case is to raise an exception whenever there is any condition not met, or raise an exception whenever there is something in the argument that failed. So it is much better to rewrite this code snippet and raise a value error if it is not the same. This will make your code, in this way, caller don't have to rely on your return type, and caller can wrap the calling this function into try except and log its own error if there is an error or exception raised in this function code. Now, this is an interesting one, that is dynamically creating variable, method, and function names. I will give you a minute a second to go through this. So if a function that is supposed to, sometimes a programmer gets an idea to make life easy by creating a magically working code that use getter setter function to set some variables. While this may look like a good idea because there is no need to write all the method by hand, it still causes some error to us. For example, in this method. Now, as it is, it looks fine and it is doing the thing as it should do. It can cause a problem in longer run. Let's say for in this class, now we have modified it, and what it will do is the class contain also unknown variable that is indexed by their count. So it will be difficult for us to figure out from where these variables are coming from. While the approach and example may be easier to write, but it will be very difficult to maintain it later, especially when somebody else is maintaining your code or trying to extend your code. So we should always find other ways to, we should find other ways to implement the same idea. Maybe use a function to pass the incoming data, or use the data dictionary itself without the class. But again, this depends upon the task in hand. If it is small, easy, and straightforward, this is good. If it is going to be there in longer run, let's look into the other approaches we can do. Now comes the readability. We should prioritize writing clean and readable code that works first, using known and testable algorithm and tools. Then we should work on making it more optimal and more precise, because sometimes making the code precise or optimizing it take away the readability factor, and it is a problem for your code reviewer. The first one is not using dictionary keys when formatting the strings. Now here we have a dictionary of person, and we are trying to generate a string using the values of the keys in that dictionary. It is fine if your dictionary size is small. You know at which index which key will go. But suppose you contain a dictionary with the size of 15 keys and you're trying to generate a string out of it. There it will be a problem, because if you mess up even a single index, the meaning of whole string will change. So it is advisable to use the keys itself and then extract the values of the dictionary in the string, because it makes it, now we know exactly the key we are referring to at a particular index. It makes your code more readable and understandable, and the NP person will know, whoever is reviewing your code, that which key is expected to be here. Okay, comparing things to true the wrong way. Yes, this is something which is very general for us. You should have seen this code many times, especially from the people who are junior, and they compare the true, something like this. So the purpose of PEP 8 style guide is to improve readability of the code. For sure, so this is not an anti-pattern in Python itself. This lies in almost every programming language. This is good. You can do that, but it is not advisable. I would say the most advisable part is to check if flag. That's it. Unless you want to differentiate between true and the non-empty list. So in the end, you compare a boolean with the actual boolean only when you make actual distinction between true value and every other that can be treated as true. If you just want to consider it as true, then just go with the second one. Not using zip to iterate over a pair of list. Yep. So this is something which is also you must have seen in longer run. You will see that when you have two lists and you want to iterate over them, so you will just call the length of one, go through its range, and use the index to pick the coordinated value. This will do the job which it is supposed to do, but preferred way to do this is to use the zip. The preferred way to iterate through a pair of lists is to declare two variables and then call zip, because zip will take care of indexing items in the for loop, and it will always keep track of which for variable is getting mapped to which zipped list. So it is always cleaner to read, and the end person will understand what you are trying to do. Now the fourth is using unpythonic loop. Now creating a Pythonic loop like this, suppose you want to iterate over a list, it will do the job by indexing the list and incrementing it to access each element is doable, but it is not preferred style. The preferred style is to use enumerate to simultaneously retrieve the index and the value at that index together. Not using name tuple. Now this is something which you must have seen many times in your day-to-day work. You have a function and you're trying to return a tuple. Now when you return a tuple, you can always use index, and then you can retrieve the value at a particular index and it do the job. But in this code is difficult to use, because the caller of function has to know the first element is the first name, the second element is the second, and third is the last name. If at any point they mess up the index mapping, they will end up getting different strings at different places. So what is advisable is to use the name tuples. Name tuples are always good, because name tuples help you in returning multiple values. They can be used anywhere where normal tuples are acceptable, but their values can be accessed through their names in addition to their index. This makes the code more verbose and readable. Now, the last part of any code review process is figuring out how the particular code change is performing. Is it good? Is it bad? Is it improving the performance? Is it making our code slower or what? So there are always anti-patterns that contribute in slowing down your code or slowing down your process. Let's have a look at them. So this is a common way of iterating through a list if we want to figure out something exists in a list or not. You check if it is there or not, you check every element in the list. If it is not there, you return something or print something. If it is there, you return something else. Although it is good when you have a small list, suppose you have a list of 10,000 items and you're going to check it extensively in your code, it makes more sense to use set, because checking an element in set is always a constant time, and it makes sure that in a constant time, it doesn't matter on the list, it will always make sure that you're getting the response in the designated time. So it will always be faster and it will improve the performance of your code, because your function which is checking the item in list is responding faster. Second one, not using iter items to iterate. Now this is very specific to Python 2.7. If you're using Python 3.8 or Python 3 in general, this thing doesn't exist. I mean, iter items doesn't exist. But there are many people who are still using 2.7 and they complain about slowness in their dictionary values. So most of the time they are not using iter items, and they use iter items to improve the performance in that part of the code. Let's have a look at you have a dictionary of a huge number of numbers, and what you do, you go through each item if you want to print the key and the value. In 2.7, to be more memory efficient, it is advisable to use the iter items because it is not memory hungry. Not using literal syntax to initialize empty. Yep. So this is something, you have a variable you want to initialize as a list. You can call the list function, of course. But as soon as you call a function, your Python will first check the local scope and then the global scope to figure out if there is any function with the name list or not. And if it is not, then it will move to the built-in libraries. Now, this process sometimes takes more than expected time. To handle this and make sure that even if you can improve it by, let's say, 5 seconds, it will, or let's say by 0.5 seconds, it is a big improvement in your code. So it is always advisable to use the literal, because it will make sure that you are calling the empty list or empty tuple or empty dictionary instead of calling the function itself. They still do the work that they are supposed to do, but literals are always faster. Premature optimization. Yes, this is something which is a big problem, because if we optimize for performance before setting up an effective architecture, we may lower code readability and make our code more hard to maintain and more hard to debug, and maybe we will end up adding superfluous part to our code, which we don't want. So it's always advisable that before optimization, make sure that you have the whole architecture ready, you have POC implemented, and before even the last step before optimizing your code, you profile it. You should know which part of your code is slow, and then you focus on only those parts. Because without that approach, you may end up optimizing the part which don't need optimization at all. Maybe they are as fast as they can ever be. So profiling is very important. You profile your code, you make sure you have improved your code and all the bottlenecks are removed. You have handled all the exceptions, you have handled all the corner cases, you have handled all the places um, where the anti-patterns can make it look bad, or it is, you might have not ended up over optimizing it. Yes, there is a, believe me, there is a term, something which is called over optimizing it. So you make sure that all these things are in place before you optimize your bottlenecks. And it is always important to know where the optimization should lie. Now, one approach for optimization that I have seen, of course, profiling is very important. Second, you should not create something which you may use in future. Let's say you are writing REST APIs in Django and you have written an API which will return the device name. Okay, in the REST API, you have two REST API, one is post, one is get. Post give you the name of the resource, and then in the get you are returning the name of resource. And you might think that, hey, maybe because I'm returning the name of the resource, at the same time, let's say that the resource is a device, maybe phone, laptop, tablet, anything, and you want to return the device type as well. Maybe in future the end user or the UI which is consuming this API will end up using that particular field as well. But in longer run, this approach is good, that you are trying to provide something which they may need. But if you look at the longer run, if they don't consume that particular field at all in next 3 or 4 months, that field is a waste, because it is contributing to the total payload of your response. And if there are numerous devices, let's say there are 100 device names that are going in response in get all list, then the device type is going implicitly and your response payload size will increase, which you don't want. You can just decrease the payload response size by 50% just by removing a field that you think you will need in future. So in the nutshell, don't add or don't put anything in code which you may need in future. If you need anything in future, add it into code in future. Don't need anything right now, because your requirement will change over the time. So in conclusion, don't do it. These anti-patterns are there to help you understand that these things contribute into the problems that arise later in production or during the review. These anti-patterns may or may not pose big risk for you, but if you can avoid them, it will be happy. You will feel more happy, and it will be more useful in the longer run, especially for your code. Please always follow PEP 8, because they are there to improve your code readability and make sure that it is properly structured. So thank you for listening to our talk. Happy coding.
Okay, I was about to warn you about the time limit, but this just about right. So we already have one question. It's really long, so wait. Okay, so for a question, do you have any suggestion on how we can encourage students or junior engineers so that they can have clean coding habit? Because most of the time the focus is to finish the project without that, I'm assuming.
Yep. So suppose you are a student or a junior engineer. If you are a student and you are creating a project, which is for your final term, or this is not going to be there in longer run and you are tight on the time, obviously first create something that work. Now that is the deadline, because if you, it doesn't matter how beautiful your code is, if it doesn't work as it should, it's a problem. Now when you develop, suppose you have sufficient time with you. So by sufficient time, I mean that you have a day extra than what you're supposed to have. Then focus on the style and go through PEP 8 and go through the problems that can rise in your code. First write a plus b equal to c. Let me take the example of a plus b equal to c. First write a function that will return a plus b equal to c. Now look at that function and write test cases. Test cases means call that function using different kinds of A and B, the argument you are accepting, and it should handle all of them. Now, if you're a caller function, suppose you are an end user, you want to make sure that your code is working as it should. So you are going to check every corner case in that. Is a plus b equal to c is getting returned as it should for all kinds of literals, or for all kinds of numbers? Or if your function is meeting the standards of PEP, maybe you have handled everything in try and accept, and you have put exact exception that it should be handled, but you have not used the proper variable names. So again, it depends upon the task in hand. If your code is going to be one time only, and if it is going, or if it doesn't have a significance after 1 month, or even if you want to improve your coding style, go through PEP 8 whenever you have a confusion that is this the right way to name your variable or name your function, or are we supposed to compare it with true, or are we supposed to compare it with none? Let's just say that if ABC is none, if ABC is none, sometimes we do this comparison. Don't do it if it's anyway handling that comparison for you. If you add it, you are doing it 2 times, which is not advisable. So go through the PEP 8, and when you want to have a clean coding, make sure you have somebody with whom you can share that code and get their comments that can improve your coding skill. If you're a junior engineer, always have a senior who is going to mentor you and guide you that, okay, this thing can be improved like this thing can be improved like this. So, because there are, suppose when you work in a college, you always pick the latest Python 3. Now, when you go to work, now it's Python 2.7. There are few things in Python 2.7 which are no more in Python 3. And there are few optimization that you can do in Python 3 code, which if you do in Python 2.7, it will make your code slower. These things come only with experience. So go ahead, raise your pull request, keep asking. And the best way that I have found in improving your coding is contributing into open source. They are like the best place to improve your coding, because the people over there are very good and they always welcome you. Yes, there are people who may not, but it's always good versus bad and what you can get out of it.
Okay, next question. For Mas Irfan Putra, what testing frameworks do you use?
I use PyTest. Then we have used Jenkins, and we have used nose test. Then we use Postman for the APIs. I use locals as well for stress testing, if when we do it for APIs. And of course, unit testing that gets written inside the Django and Python, those.
Okay, there's another question. Some of the case maybe can be handled by linter. Do you have any recommendation on linter on Python?
Okay. In all honesty, I've not used linters. I'm very old school in that, because the coding that I have to do in last 5 years in Python is usually on secure projects. So we have to be very, we don't get that much frameworks or the other things to get Python. We only get Vim and the Python install. So lentils, if you can give me some time, I will get back to you on that.
Okay. There is a bit of time left. Probably anyone want to ask the last question? Maybe I will wait for a few minutes. Last chance for another question. If there's no other question left, probably Pratibha, you will have some final remark for the audience.
I know that my my talk is about anti-patterns. There is no hard and fast rule, or there is no checklist that, okay, if these anti-patterns are not there in your code is going to be good, or if they are there, they're going to be bad. It all depends upon your task in hand. Make sure that you're using Python optimally before you release your code into production. I just had a hinge to look into the linters, and I see that it's a source code analysis tools. So, of course, you can always use static analysis of your code to improve it. I sometimes, when I do for my personal project, I use PyCon. It has the static source code inspection. It's good. It always tells you what can be done and what cannot be there. So, always make sure that you are working on improving your code style, because it always helps to know these corner cases. When you look, as you go higher in hierarchy in IT industry, you will realize that most of your work will revolve around solving the bugs instead of creating the actual code. You either will be designing the solution for a major production flaw, or you will be fixing the production bugs or the bugs that are there in the backlog. So make sure that you are aware of these issues so that you can first look into and see that if they are not there, if they are the reason behind the issue. So happy coding, and I hope you have enjoyed the talk.
Okay, thank you for the amazing talk you have shared with us. That was really heavy material, but it has tons of great insights for us. So thank you so much, Pratibha, and also for all you who watched this session. Allow me to close this session and see you soon in other sessions. Thank you so much, Pratibha.
See ya, bye, Lutfi. Thank you.